So the learning objectives are to understand and use the inverse sine and cosine and tangent functions. And by the way, this is 8.3. Find the exact value of expressions involving the inverse sine and cosine and tangent functions, and use a calculator to evaluate inverse trigonometric functions. Find exact values of composite functions with inverse trigonometric functions. So that's what we're going to be doing in this section. And I'm going to remind you some of the definitions. Definitions of reciprocal functions. So secant, we know it's hypotenuse over adjacent, or 1 over cosine. Okay, and then cosecant is the hypotenuse of an opposite, or 1 over sine, and cotangent is 1 over tangent. So what we're going to focus on, we're going to be focusing on the inverse functions of sine, cosine, and tangent. That's the only inverse functions that your calculator has as well. If you look at your calculator, it has inverse sine, inverse cosine, and inverse tangent. It doesn't have inverse secant, cosecant, or cotangent. So the way we're gonna go about figuring out those functions is through sine, cosine, tangent, and applying our reciprocal identities. Okay, let's continue. So notation for the inverse functions. So if f of x is sine of x, then the inverse function looks like this. It's f, and then we have a -1 there. Well, usually, I don't know why it's after x. Usually it's like right there before x, so, next to the f. And this is another way of writing it. So it's sine with it's not another way. It's the way that we talked about so far. This is sine with a -1 above it, like in the position where, in a superscript where your exponent usually would be. But because it's applied not to a value, but to a function name, that's how you know it's an inverse function. Because like when we apply this superscript of -1 to a sine function, to a value, that's a reciprocal. But here it's not a reciprocal, it's an inverse. Okay, now another way of writing inverse sine is, or notating it, is an arc sine. Arc sine of x is the same thing as sine with a -1. So this is just another way of writing it. All right, so and like we said, since sine of pi over 6 is 1/2, then we know that the inverse sine of 1/2 is pi over 6. The cosine of pi is -1, so the arc sine of or inverse sine of -1 is going to be pi. So again, let's write those other notation. It's the same as cosine with a -1 above it. And this is the same as yes, sine with a -1 above it. I guess it's another notation. They tried to make it unique and not use the subscript because it may be confusing. Okay, and arctangent. Arctan. Oh. Okay. So let's let's calculate it. This given sine of pi over 2 equals 0.96593, write a relation involving the inverse sine. So basically there are no unknowns here. They just want us to rewrite using this expression that would say the same thing, only using the arc sine or inverse sine. So we would say that the inverse of this value, because this is a sine value, and if we invert it 96593, we're going to get our angle 5 pi over 12.